All right, guys, a quick review today of solving systems of equations. You did this last year back in ninth grade, and hopefully you're pretty familiar with the process. If not, this will be a quick little refresh before we solve systems of equations with quadratics. If you notice on the notes, these are just linear equations that we're going to do today. Next time we'll move into the quadratic equations. So here's the problem that we have. X plus 3y equals 5. I can solve for x by moving the 3y to the other side, and I get x equals 5 minus 3y. But I still don't have a specific answer for x. I still have a variable, this y, in the way. And it goes the same. I can also solve that same equation for y. I can minus the x, and then divide by 3. And I end up with y equals 5 minus x divided by 3. Again, I don't have an answer for y. And the problem is we need another equation. So to solve an equation with two variables, you need a second equation to help you solve the first. Now, the solution that you're going to get is actually going to be true for both of those equations. So I'm going to show you three methods today. And the nice thing about the three methods is it doesn't matter which one you use. You've just got to pick the one that you like, that you're comfortable with, or maybe you like to use a different one in different situations. So first way to solve this is by substitution, which is what you probably do already. This is the way that you naturally have been solving these problems. So here's my example. X plus 3y equals 5, but I need that second equation, which is negative 2x minus 4y equals negative 5. So these two equations together make up a system of equations, and I want to know what's the solution, what answers, what x and y value works for both of these equations. So step one, solve one of the equations for one of the variables. And I made a recommendation here that you pick the easiest equation and you solve for that one, which usually has no coefficient, which in our case is going to be this one right here. I have x plus 3y equals 5. I want to solve for x because there's nothing else connected to it. So it gives me the nicest answer. So I'm going to get it by itself. I'm going to minus 3y from both sides. So x equals 5 minus 3y. That's my step one. Get one of the variables, solve for it, get it by itself. Step two is we're going to substitute this new equation that we solved for. We're going to substitute that value into the other equation. And I put other in big letters here because we've already used this equation. I can't use it again. I'm going to take this x value and I'm going to plug it in to the other equation. And I'm going to simplify it. So I have negative 2, and instead of x, I'm going to plug in my value for x, 5 minus 3y. So 5 minus 3y. And then I minus 4y equals negative 5. So now I just simplify. I distribute the negative 2. I get negative 10 plus 6y minus 4y equals negative 5. And now I combine those like terms. So negative 10 plus 2y equals negative 5. All right. I only have one variable left in my equation. So the nice thing about this is I've gotten rid of all the x's. All I have is a y. So I can actually solve my equation now, which is step 3. So I have negative 10 plus 2y equals negative 5. So I can isolate my variable now because there's only one variable. So I'm going to add 10 to both sides. So 2y equals positive 5. And then I'm going to divide by 2. So y equals 5 halves. Which I know a lot of you don't like fraction answers, but too bad. You're going to start getting them today. So my y value that is true for both of these equations is when y equals 5 halves. Now I need to figure out, well, if y is 5 halves, what would my x value be? And to do that, I just plug my y value into one of the original equations. And the nice thing about this step is it doesn't matter which equation I use. I can pick my x plus 3y or this bigger equation. I'm going to pick the simple one, x plus 3y. So I'm going to take x plus 3y equals 5, I think, or negative 5. I better double check. Equals positive 5. And I'm going to plug in my y value. So x plus 3 times 5/2 equals 5. So x plus 15/2 equals 5, which means I need a minus 15/2 minus 15/2. So x is going to equal negative 5/2 after I do that arithmetic. So my solution to this system of equations is y equals 5/2 and x equals negative 5/2. And I'm going to write that. A lot of times we write it in an ordered pair, especially if we're dealing with x's and y's. That would be my answer because it's true for both of these equations. If I plug it into here, I get 5. If I plug it into this one, I get negative 5. Okay. So let me give you a couple more examples, and then I'll let you try one on your own. X plus 12y equals 68. X minus 8y equals negative 12. I need to solve for a variable. So I'm going to solve for the x in this first equation right here. So x plus 12y equals 68. I just have to minus 12y minus 12y. So x equals 68 minus 12y. Then I'm going to take that 68 minus 12y and I'm going to plug it in for x. In my second equation, I've already used this one. I can't use it again. So 68 minus 12y minus 8y equals negative 12. From here, I just combine like terms. Negative 12y minus 8 is negative 20y. And I still have this 68 equals negative 12. Minus 68, we're going to solve for y now, minus 68. So negative 20y equals negative 80. And when I divide by that negative 20, y is equal to 4. So I have half of my solution. To get the other half, I just have to take this and plug it in. And it does, again, it doesn't matter if I plug it into the first or the second one. I'm going to plug it into this first one. So x plus 12 times 4 equals 68. So x plus 48 equals 68. So x equals 20 after I subtract 48 from both sides. So my solution would be x is 20 and y is 4. That would be my solution for that system of equations. All right. Okay, let's do one more. R plus s equals negative 12. 4r minus 6s equals 12. I'm going to use this first equation, r plus s equals negative 12, and I'm going to minus s from both sides so that r equals negative 12 minus s. And then I'm going to plug that back in for r. So 4 times negative 12 minus s minus 6s equals 12. Distribute the 4. Negative 48 minus 4s minus 6s equals 12. So negative 48 minus 10 s's equals 12. And then I add 48 to both sides. And negative 10s equals 12 plus 48. That's supposed to be a 48 right there. Equals 60. Divide by negative 10. Divide by negative 10. S is equal to negative 6. And when s is negative 6, I plug it in right here. R plus negative 6 equals negative 12. So r plus a negative 6 equals negative 12. So r minus 6 equals negative 12. So I add 6 to both sides. R equals negative 6. So my solution is that s is negative 6 and r is negative 6. That solves both of these equations. Go ahead, try this last one on your own. Pause the video, take a couple minutes and try to solve for one of the variables, plug it in, and see if you can come up with the other one. All right, so what you should have done is probably solved for this y, 5x plus y equals 0, because it's all by itself. So all I have to do is minus 5x from both sides. So y equals negative 5x. Then I plug that into this equation. So 5x plus 2 times negative 5x equals 30. So 5x minus 10x equals 30. So negative 5x is my 30. And when I divide by negative 5, x is equal to negative 6. So I'm halfway solved. Now all I have to do is plug this back into any of these equations. So I'm going to plug it into this first one right here. So 5 times negative 6 plus y equals 0. So negative 30 plus y equals 0. So when I add 30 to both sides, y is equal to 30. So my solution would be negative 6, 30. And that would solve both of my equations. All right, that's the first method. Second method, which is my favorite, and once you practice it a little bit, it goes a lot faster than our first method. It doesn't always seem like the easiest, but it does. Once you've gotten a little practice and tried a few of these and recognized some patterns, it can save you a lot of work from substitution. We call this one solving by elimination. So I have these two equations, and I need to solve this system. So step one, rather than substituting, because solving for x or y is not going to leave me with a very nice number. So instead, I'm going to write one equation over the top of the other and make sure that my variables and the constants are the same, kind of like we did back in math. In other words, if I have negative 2x on top and then 8y, and then that equals a negative 8, I'm going to write the other equation underneath it, but I want my x's, y's, and constants in the same place. So my 5x is going to go here, my negative 8y is going here, and my 20 is going to go on this side. Every once in a while, you're going to see something like maybe instead of 5x minus 8y, maybe it said 5x minus 20 equaled a positive 8y. I can't put that underneath here because my negative 20 is on this side of the equation and my 8y is on the other. So I would have to move the 8y and I'd have to move the negative 20 to get the equation set up correctly. So step two is I'm looking for coefficients that match. If none do, we're going to multiply a whole equation so that you have a match. And I'll show you an example of that in just a minute. But right now, I have an 8y and a negative 8y. And what's really cool about this method is now that I have them set up, negative 2x plus 8y equals, now I've got to remember the equation, equals negative 8. And then 5x minus 8y was equal to 20. I'm going to draw a line under here like you did back in elementary school. And I'm either going to add the second equation to the first one, or I'm going to subtract it because I want these y's to go away. And the way I decide is these two are the opposite signs. This is a positive 8. This is a negative 8. So if I add these two equations together, these are going to add up to 0. 8y's plus a negative 8y's is 0y's. So it makes them go away. Negative 2x's plus 5x's is just 3x's. And negative 8 plus 20 is 12. So my equation just becomes 3x equals 12. And when I solve that, which is step 4, I just divide by 3, x is equal to 4. I'm halfway done. And now all I have to do is plug this 4 back into one of my equations to figure out what my y value is. So x equals 4. So let's do negative 2 times 4 plus 8 times y equals negative 8. So negative 8 plus 8 times y equals negative 8. If I add 8 to both sides to get rid of that 8, this 8 actually also goes away. So 8y equals 0. And when I divide by 8, y is equal to 0. So my solution would be x is 4 and y is 0. I like this method because it eliminates equations rather than creating bigger, messier new ones. Every once in a while, you'll end up with a situation like this one. 2x plus 24y equals 136. 4x minus 32y equals negative 48. 2 and 4 aren't a match. 24 and 32 aren't a match. 136 and negative 48 aren't a match. But I can change one of these equations. I can take this entire top equation and multiply everything times 2 so that instead of a 2x, this becomes a 4x. So I'm going to redo this equation, but I'm timesing everything by 2. So 4x, 24 times 2 is 48y. And that's going to equal 136 times 2, which is 272. So I got rid of this equation, and I've got a new one. And underneath it, when I write my old equation, now I have 4x and 4x. But this time, I'm going to minus the top and bottom, because if I add those together, this is going to be 8x's rather than it go away. So 4x minus 4x is nothing. 48y's minus a negative 32. We got to be careful. 48 minus a negative actually means 48 plus 32. So this becomes 80y. And 272 minus a negative 48 means I'm actually adding 48, and that's 320. So now I have 80y equals 320. And when I divide by 80, y is equal to 4. So I can take that answer and I can plug it in right here and figure out what my x is. So 4x minus 32 times 4 equals negative 48. So 4x, 32 times 4, 30 times 4 is 120, but I have a 32, so negative 128 equals negative 48. Now to move this over to get x by itself, so I'm going to add 128. So 4x equals negative 48 plus 128 is going to be 80. Divide by 4. X is equal to 20. So my solution right here, x is 20 and y is 4. That would be my solution for this system of equations. Okay, so elimination works better, but sometimes the equation, you have to alter it a little bit so the numbers on the top and the bottom match up. Here's another example that we need to be careful of. 3x plus 2y equals 6. 3x plus 3 equals y. Notice that my y and my 3 are on the wrong side. So I'm going to move the 3 over here, or the y over here, and I'm going to move the 3 to this side. So I'm going to have 3x plus 2y equals 6 on top. When I move this plus 3 to the other side, it's going to become minus 3. And when I move this y to this side, it becomes a minus y. And I still have my 3x. So 3x and 3x, I want to minus those so that 3x minus 3x is 0. 2y minus negative y is 2y plus y, so that becomes 3y. And 6 minus negative 3 is 6 plus 3, which is 9. Divide by 3, y equals 3. And then I just plug that in right here. Let's actually do the second equation. 3x plus 3 equals 3. So if I minus 3, 3x equals 0. Divide by 3, x equals 0. So my solution, 0, 3. Go ahead, try this last one on your own. Pause the video, see if you can do it, and then restart it, and we'll see how you did. All right, so I have 2 r's and 4 r's. Those don't quite match up. But this one, I have 1s and negative 1s. So that's a great combination, and I'm going to add these two together. 2 plus 4 is 6 r's. 1s plus negative 1s makes my s's go away. And then 3 plus 9 is 12. Divide by 6, r equals 2. And then I plug that back in. So 2 r's, so 2 times 2 plus s equals 3. So 4 plus s equals 3, minus 4, s is equal to negative 1. So your solution is r equals 2 and s equals a negative 1. All right, third option. You can plug this into your calculator and let it do some of the work for you. This is probably my least favorite because there is a lot of places you can make mistakes. And the biggest reason is in order to plug this equation into my calculator, it has to look like y equals something. And right now, there's a lot going on with this equation. But we can make it work. I can solve this equation for y. And that's what step 1 is, to solve both equations for y. So negative 6 equals 3x minus 6y. I'm trying to get y all by itself. So I'm going to minus 3x and minus 3x. So negative 6 minus 3x equals negative 6y. Now I'm going to divide by negative 6 and divide by negative 6. So y is equal to negative 6 minus 3x divided by negative 6, which simplifies. You can plug it in just like this if you would like to, but negative 6 divided by negative 6 is just 1, and negative 3 divided by negative 6 is a positive half x. So there's one of your equations, 1 plus 1/2 x, or you could plug it in like this. I'm only partway done. Now I have to solve this equation for y. So 4x equals 4 plus 5y minus 4 minus 4. So 4x minus 4 equals 5y. Divide by 5, divide by 5. So y is equal to 4x minus 4 divided by 5. And that doesn't simplify at all. So there's my second equation. Now I have to plug those into the calculator. But when I do so, I could make another mistake. If I'm plugging in these big fractions, I have to make sure the top is in parentheses and the bottom is in parentheses. Okay, so when I go to my calculator and I hit y equals, if you notice, I put negative 6 minus 3x in parentheses divided by negative 6. And then I put 4x minus 4 in parentheses and divided by 5. So now when I hit graph, if I look at the picture, this is the point I'm interested in. This is where these equations are both true, right at this intersection. So to calculate that, in your notes, it tells you what to do next. You hit second, calculate, intersection. So I hit second, and this calculate right up here with trace. And I'm going to go down to intersect, which is number 5. Hit enter. First curve, it just wants me to select my first line. And I hit enter. Second curve, it wants me to select my second line. I hit enter. And now it wants me to guess. So I can move to where I think they intersect and hit enter. And it tells me that they intersect when x equals 6 and y equals 4. So my answer would be x equals 6 and y equals 4, or 6, 4. Here's my problem with the calculator. There is a lot of mistakes you can make right here solving for y. There's mistakes that you can make plugging it into the calculator correctly. So if you use the calculator, it would be a good idea after you get this answer to plug in the numbers and check. Check your answer, make sure it works. I still think method 2 is faster and easier, but this is an alternative that you are more than welcome to use. Okay, 2 situations you need to be aware of before you do the homework. Especially, this is one of those kind of key ACT things that comes up a lot. Sometimes when you use these methods, you don't quite get what you expect. So really quick, negative x plus y equals 6. I'm going to solve that for y. So y equals 6 plus x. And then I'm going to plug that in to my second equation. So 2x minus 2 times 6 plus x equals 0. 2x minus 12, because I have to distribute that negative 2, minus 2x equals 0. 2x minus 2x, those cancel out, and I'm left with negative 12 is equal to 0. That is not true. Negative 12 is not equal to 0. So if that happens, that means there is no solution. If your x's and your y's cancel out, then there's no solution to the problem, which means these lines are never going to actually cross, which means they're parallel for future ACT questions. Look at this second example. 4x plus y equals 6. So I'm going to solve this one for y. So y equals 6 minus 4x. And now I'm going to plug it in. So 12x plus 3 times 6 minus 4x equals 18. So 12x plus 18 minus 12x equals 18. 12x minus 12x goes away, and I'm left with 18 equals 18. Unlike this one where they weren't true, this one, 18 does equal 18. And what that means is that there are infinite solutions. They go forever because they're actually the same line. One of the lines is sitting right on top of the other line. So if you get the X's and Y's, if they both go away and you're left with something that's not true, that means there's no solution. If you're left with something that is true, that means there's infinite solutions. And you are going to see that. It will come up. Just be careful that when you're plugging this in, you plug it into the second equation. Don't accidentally solve the first equation and plug it back into itself, because that's not going to get you the correct answer. All right, homework 16. There are 12 questions, I think. And it's due on Wednesday, which will be the 14th. Get that homework done. If you have any problems, come in and see me. I'll do what I can to help.